Welcome back, everyone. Today we are going to be going through the four types of conic sections, and we're also going to be classifying each of these as one of the conic section types from before. So let's dive in. So there's four types of conic sections. The first one here is the ellipse. So the ellipse has the form x squared over a squared plus y squared over b squared is equal to 1, and it has a major axis and a minor axis, and presumably the major axis and the minor axis are different, but they also could be the same. And that actually brings us to circle. Now, a circle is actually a special type of ellipse because you may notice that in the ellipse equation, if a is equal to 1 and b is equal to 1 and r is equal to 1, then we have a circle equation. Or even if a squared, or even if a and b from the ellipse are the same number, then we could just combine the fraction and then multiply by whatever a squared and b squared are on both sides and end up with the circle equation there. And so if a and b are the same on the ellipse, meaning the major and the minor axis would be the same, that tells us that we have a circle, which is a special type of ellipse. So all circles are also ellipses, but not all ellipses are circles. The key characteristic being that in a circle, there's just one radius, and so therefore the major and minor axis are the same. Whereas with an ellipse, they could be the same, which would make that a circle as well, or they could be different when we're talking about an ellipse. All right, so let's move on to the parabola. The parabola can be just a regular parabola, like what we're used to seeing from Algebra 1 and Algebra 2, like the first one, or it could be the inverse of an original parabola. We would still consider that a parabola, though, either way. If the parabola is up and down, then it would have x squared as the equation, so it would be the second one. And if it's a side-to-side parabola, right, so like the second parabola over here, that would actually go with this first equation. The y squared is equal to 4ax equation there. And then last but not least, we have our hyperbola. The hyperbola equation looks pretty similar to the ellipse equation, but notice here we have a key difference. We have a subtraction sign instead of an addition sign, and it makes all the difference to how this looks, right? The hyperbola looks quite different from the ellipse. Okay, now let's go over some examples and just decide which type of conic section each equation is. And remember that every time we say something's a circle, we also have to state that it's an ellipse. If we're asked to give the best or the most specific answer, we can just say circle. But if we're asked what are all the ways we could characterize a certain conic, then if we say something's a circle, we also must say it's an ellipse. Okay, so the first one here, x squared plus y squared is equal to 9. Well, that would be a circle because that goes with the x squared plus y squared equals r squared equation, where r is 3 in this case. So this would be a circle. And because all circles are also ellipses, we would also say ellipse. Okay, the second one, 4x squared plus y squared is equal to 16. Well, for this one, the denominators would not be the same, right? The first one, x squared, has a denominator of 1/4, hence we have 4x squared. And then y squared has denominator of 1. So since they have different denominators, this would be an ellipse. All right, what about this next one? Negative x squared plus y is equal to 4. Well, this would be the equation of a parabola, right? Because notice we just have, we have x squared and we have y here. So this would be the a parabola. We could rearrange this in order to get one of the equations as before, x squared equals something or y squared equals something. So we could certainly do that here. We could add x squared to both sides, and we could subtract 4 from both sides to get that x squared is equal to y minus 4, like that. So that's certainly another way we could rewrite this to show even further that it must be a parabola here. Then we have x squared minus y squared is equal to 1. Now that's going to be a hyperbola, right? Because here we have a minus sign instead of a plus sign here. So this would be hyperbola. Then this next one here would also be a hyperbola because it has both x squared and y squared on the same side, but they have opposite signs. We have positive y squared and negative x squared. So whenever we have that, whenever they have or opposite signs, that tells us it's a hyperbola. And then this last one here is an ellipse because the coefficients here are, yes, they're both positive, so it wouldn't be a hyperbola, but they're both different and they would have to be the same thing in the event that we had a circle. So this would be an ellipse. As always, let me know if you have any questions down in the comment section, and we'll see you for the next one.